Hi, I'm Bianca Coker, a math consultant at Region 10. And in this video, we're going to talk about some of the new math standards in 6th grade. And these standards are in the expressions, equations, and relationships strand. Now, I'm going to give you a twofer on this one. I'm going to talk about two different standards because they don't really make sense by themselves, and we can really see how they support each other. And that kind of brings up a little point I wanted to make, and I wanted to share this with you. If you haven't been in one of my trainings, we as teachers are breaking down these standards, trying to really understand them, exactly what they are and exactly what they can do. And there's lots of documents out there that you may be accessing that break down these standards. But remember, when we teach them to our students, we've got to teach them bundled. We've got to teach them together, connected, so that they understand how this all fits back together. So while we might be looking at individual puzzle pieces, we want to be showing our students a much bigger picture. So when I looked at doing this video, I thought, I really can't do these two alone. It makes no sense. Let's do them together. So let's see how this one goes. All right, this is 6-9B and 6-10B. Let's look at 6-9B and what that says first. 6-9B states that the student applies mathematical process standards to use equations and inequalities to represent situations. The student is expected to represent solutions for one variable, one-step equations, and inequalities on number lines. So looking at that standard, I focused in on representing solutions on a number line. That's really what we're talking about. So, if we are representing solutions for one variable, one-step equations, and inequalities, that means that once we've solved those equations and inequalities, we're going to provide a graphical representation of that solution. Well, it's kind of interesting. Let's look at these two examples. 3x equals 9 and 6 plus x is less than 9. Well, we're going to break it down and we're going to look at each one. So 3x equals 9. When we solve this one-step equation, we do our simple step of either multiplying both sides of the equation by 1/3 or dividing both sides by 3, and we come up with the answer of x equals 3. But that's for another video. But once we get our answer, x equals 3, we want to represent that on a number line. Well, here it is. There's 3 on our number line. It's a little simple, isn't it? Now, I could see the need for doing this if we're working with the number line model and we're getting our students familiar with that. But really, by itself, it doesn't make a whole lot of sense. What we really want to do is represent inequalities on a number line. Now, let's look a little further and then we'll come back to that one. The 610B says the student applies mathematical process standards to use equations and inequalities to represent situations. The student is expected to determine if a given value makes a one variable, one-step equation, or inequality true. So this is that check your answer kind of thing, right? And the reason why I'm jumping into this, you'll see in a moment. So, in this standard, we're determining if a given value is true, if our answer is correct. Well, how do we know if something is a solution to an equation? That's my first question for you. Most of the time, we just try it out. We plug it in and check. Our students' favorite method is guess and check. And here we go. We have a supposed solution. Let's just check it out. So your students will be very happy with this. We just try it out, plug it in and see. So, in this equation, 2 plus x equals -5, our solution, solving this one-step equation, would be, looking at our algebra tiles, we have 2 plus x represented on the left and 5 negatives represented on the right. Now to solve this equation, we're going to add the opposite of those two ones to our left side because we want to get our zero pairs and end up with 1x. Right? That's our whole point, 1x. So we're going to add our two negatives to one side. But notice how two negatives popped in on the right side as well. One of our properties when we solve equations or when we work with algebra tiles is that whatever we do to one side of the equal sign, we have to do to the other. So if I add the two negatives I need to get my zero pairs on the left, I have to add two negatives on the right as well. That's okay. We can do that. Now, we have our 0 pairs. We have those 2 0 pairs. Those are 0. So really all I have left on the left side is my x, and on the right is 7 negatives. So let's look at symbolically what happens. In this situation, we had 2 plus x equals negative 5. We added negative 2 to both sides, and we end up with x equals negative 5. All right, now let's plug in our solution, negative 7 in place of x. So 2 plus x equals negative 5, so 2 plus negative 7 equals negative 5. 2 plus negative 7, negative 5. So we have negative 5 on the left, negative 5 on the right. Is negative 5 equal to negative 5? Yes. So this situation is true. If I plug in negative 7, I get a true answer. And that verifies that the solution is correct. Now remember that represent our solutions on a number line. Then what we're going to do next is we're going to use that same thing we just did with our inequalities and see how we represent our inequality example on a number line. All right? Remember that inequality. It was 6 plus x is less than 9. Now, if we solve this equation, we would know that the answer for the equation is 3. 6 plus 3 is equal to 9. So we think that 3 is an important point. So we put 3 into our inequality, and we have 6 plus 3, and we ask ourselves, is that less than 9? Well, it's actually false, because 9 is not less than 9, is it? So we mark that check as false. Now, let's look at another point. Let's go to 0. 0 is one of my favorite test points. 6 plus 0, is that less than 9? Well, that's true, because 6 is less than 9, right? And then I'm going to go beyond 3 to a larger value. I'm going to choose 4. So in place of x, I'm going to put 4, and I'll have 6 plus 4. Is that less than 9? 10 less than 9? No, that's false. So the way we're going to do that is we use our solution for the equality, 3, as our critical point. And it's our critical point, so I always tell my students just circle that on the number line, a nice open circle. And then we check our critical point to see if it's a solution for our inequality. Sometimes it is, and sometimes it isn't. So 6 plus 3, is that less than 9? Our answer was false, so it's not a solution. And basically, if it's not shaded, it's not in our solution set. So we leave that circle open. Now when we checked 0, we were checking to the negative side, don't know what side it is, sorry, of 3, our critical point. So we plugged in 0 and we got a true statement. So that means that that whole side of 3 is going to be shaded. When we checked 4 on the other side of 3, we came up with a false statement. That means that nothing on that side of 3 is a solution. So we know how to shade our number line. We're going to shade our number line with a ray that starts at 3 but does not include 3, going all the way out towards all the numbers smaller than 3. The answer to our inequality is all values x that are less than 3. And this is a graphical representation of that solution. I hope that makes sense. If not, rewind. Have a great day.